Welcome back. So far, we've explored how you entered full stack engineering and uncovered the realities that every software engineer eventually experiences. Now it's time for everyone's favorite part of the podcast, the stories. Every software engineer has projects they'll proudly talk about and projects they'll never forget because of everything that went wrong. Let's begin with a project that almost failed.
I think every engineer has at least one. One project that still stands out was an e commerce platform for a fast growing retail company. The deadline was tight because they wanted to launch before a major holiday shopping season. For months, everything seemed to be going perfectly. The front end looked great, the back end passed all our tests. Payments worked, inventory synchronization worked. The application performed well with our test users. We were confident. Launch day arrived. Thousands of users logged in. And within 15 minutes, the website became painfully slow. Eventually, it stopped responding altogether.
That must have been incredibly stressful. What caused it?
At first, everyone had a different theory. Some thought it was the front end, others blamed the back end, someone suspected the cloud provider. We could have started changing things immediately, but instead we followed a structured debugging process. We gathered logs, checked server metrics, reviewed database performance, analyzed API response times. The real issue turned out to be much simpler than we expected. One database query that worked perfectly with a few thousand records became extremely slow when millions of records were involved. Every customer request triggered that same query. Under heavy traffic, the delays multiplied until the entire application slowed down. Once we optimized the query and introduced caching, its performance improved dramatically.
That's fascinating. So the application worked correctly, it just wasn't prepared for real world scale.
Exactly. One of the biggest lessons in software engineering is that an application can be technically correct and still struggle in production. Real users behave differently from test users. They click faster, they open multiple tabs, they refresh pages, they use different devices, they generate unpredictable traffic. Engineering isn't just about making software work, it's about making software work reliably under real world conditions.
Let's talk about something a little lighter. What's the funniest bug you've ever encountered?
This one became legendary inside our company. We were building an online appointment booking system. Everything looked perfect during testing. Then one morning, a customer reported that every appointment was appearing one day earlier than expected. At first, we thought users were entering the wrong dates. Then we suspected the database. Eventually, we discovered the real issue. Different parts of the application were using different time zones. The front end displayed local time. The back end processed UTC. The database stored timestamps differently again. Individually, every component behaved correctly. Together, they created complete confusion. It was a valuable reminder that distributed systems need consistent rules.
That's something most people never think about when using an application.
Exactly. Users simply expect software to work. Behind the scenes, there are hundreds of small engineering decisions that make those simple experiences possible.
What's the biggest engineering mistake you've personally made?
Early in my career, I focused too much on writing clever code. I believed shorter, more complex code made me a better developer. One day, another engineer had to maintain something I'd written. They looked at it and asked, "Can you explain what this does?" Even I needed a few minutes to understand it again. That was embarrassing. I realized something important. Software isn't written only for computers. It's written for people. Clear, readable code saves time, reduces mistakes, and makes teamwork much easier. That lesson changed how I write software today.
That's a lesson many beginners probably don't hear often.
Absolutely. The best code isn't always the shortest. It's the code another developer can understand 6 months later. Maintainability is just as important as functionality.
Let's talk about customers. Have you ever worked with a particularly challenging client?
Yes. One customer wanted us to build a custom business management platform. Every meeting ended with new requirements. Initially, we tried to accommodate every request immediately. Soon the project became difficult to manage. Features kept changing, timelines slipped. The team became frustrated. Eventually, we paused development and organized a workshop with the customer. Instead of asking, "What feature do you want next?" we asked, "So, what business problem are you trying to solve?" That single conversation changed everything. Many requested features weren't actually necessary. Once we understood the real objective, we built a simpler, more effective solution. It taught me that successful software starts with understanding problems, not collecting feature requests.
That seems to be a recurring theme across engineering.
Very much so. Technology should serve the problem. The problem shouldn't be forced to fit the technology.
Tell us about a production incident you'll never forget.
One evening, we deployed what seemed like a very small update. Just a few minor improvements, nothing risky. Within minutes, customer support phones started ringing. Users couldn't log in. Our authentication service had stopped working. Fortunately, our team immediately rolled back the deployment. The application recovered within minutes. That experience reinforced two important lessons. First, there is no such thing as a small production change. Second, always have a rollback plan. Modern software development isn't just about deploying quickly. It's about recovering quickly if something unexpected happens.
That probably changed your deployment process.
Completely. After that incident, we introduced additional automated testing, deployment checklists, staging environments, and peer reviews. The mistake was expensive, but the improvements prevented many future problems. Sometimes your biggest mistakes become your best engineering teachers.
Many learners think debugging is frustrating. Has your opinion changed over the years?
Completely. I actually enjoy debugging now. It's like solving a mystery. Every log entry is a clue. Every error message tells part of the story. Every failed test eliminates another possibility. Good debugging isn't guessing. It's collecting evidence until the answer becomes obvious. That's one of the most valuable habits a software engineer can develop.
If you could give one debugging tip to every beginner, what would it be?
Don't immediately assume you know what's wrong. Observe first, read the logs, reproduce the issue. Understand the system, then begin making changes. Randomly changing code usually creates more problems than it solves. Systematic thinking always wins.
After years of building software, do projects still surprise you?
Every single one. Technology changes, customer expectations change, business requirements evolve, new security challenges appear, new devices emerge. Every project teaches something different. That's one reason full stack engineering remains so exciting. There's always another problem to solve and another opportunity to learn.
Before we finish this segment, could you summarize software engineering in one sentence?
I'd say this. Software engineering isn't about writing perfect code the first time. It's about continuously improving systems until they reliably solve real problems.
I couldn't think of a better way to end this chapter. Today's stories reminded us that successful full stack engineering isn't about avoiding mistakes. It's about learning from them, building reliable systems, communicating effectively, and constantly improving both the product and ourselves. In our next segment, we'll step into your daily life as the founder of a full stack startup. We'll follow your day from morning to evening, exploring planning meetings, coding sessions, code reviews, deployments, customer discussions, and the teamwork that brings modern software to life. Stay with us.